Hi everyone. I hope you all are doing good and healthy. So in my today's topic, I'm going to explain the concept of Azure Application Gateways or application gateways, okay, which are basically meant for load balancing for enterprise grade applications basically. Okay, so let's start with this. So on a high level, how an application gateway works, okay? A browser or a user agent sends a request for your application, okay, with the server's host name. Okay. Now, when that request reaches your application gateway, which is basically a front-end IP address, do remember that application gateways always deal with only one IP address, which is a front-end IP address. Okay, which is a single IP address associated with your application gateway. Okay. Now, the moment the application gateway receives a request from a user agent or browser, okay, it will check for the existing HTTP listeners. Okay, it will check the HTTP listeners and check to which particular listener this request needs to be forwarded. Okay, suppose if you have, for example, four applications, say you have a back office application, you have a front office application, and you have, say, you have one chatbot application. Okay, and you have some other API. In that case, what this application gateway does is simply take that request and forwards it to your listener. So what happens is basically the HTTP listener should be matched with the incoming request. There will be a n number of listeners, and based on the host name, basically based on the host name or the uh, app service specific host name of that particular web application, the listener will identify the right listener associated with it. Okay, and then it will forwards it to rules. Okay, and what are the rules? Rules are basically some conditions, I can say. Okay, some conditions. So what do? They simply check the HTTP setting. Okay, they simply check the HTTP setting where a mapping has been defined. Now, for this incoming HTTP listener, okay, for this incoming HTTP request, we found the appropriate listener. Now, for this listener, what is the target backend pool? Here, backend pool or target pool is nothing but the actual server which is going to serve the request sent from the browser. It may be a VM, it may be an app service, okay, it may be some other service. So who will decide that? This rule will basically go into its map or a dictionary, and it will simply check, okay boss, for this particular listener, who should be the backend pool? Okay, this is one web application, so there is one web server, sorry, an app service, Azure app service is associated with it. So that setting will be predefined, and what it does is basically it will forward that request to that app service, and app service does the processing and returns the response. So on a high level, this is how an application gateway works. Okay, so just imagine that an application gateway is like someone or some gatekeeper. Okay, and what is his responsibility? His responsibility is to put each and every incoming person into their right position. Take an example of a party function. Okay, take an example of a party which is being hosted in a hotel. Okay, and for this party there are a lot of guests coming, and those guests are categorized into three categories. Okay, the first category, the people who belong to first category are belonging to the Z plus security category. Okay, second category belongs to the VIP category, and third category belongs to the normal audience who will sit in the backside. They will enjoy, they will dance, yeah. So just an example. So understand that this gatekeeper's responsibility is to check the pass. So this guest will come up with a pass. In our case, browser will send a request, that is the ticket or pass. Based on that pass, he will send them into their right position. So this is how we can conceptualize the concept of application gateways. So let's move on how we can achieve this with Azure, basically the Azure cloud technology. So what do they say? When I click on a create resource and select application gateway, So as an overview, what I get is Microsoft Azure Application Gateway provides an Azure managed HTTP load balancing solution based on layer 7 load balancing. Application load balancing enables IT administrators and developers to create routing rules for network traffic based on HTTP. The application gateway service is highly available and metered. Okay. And also Microsoft Azure provides a 99.95% uptime SLA for application gateway cloud services having two or more medium or large instances. Okay. So that's what it's a layer 7 load balancing application gateway, which means not only you can load balance at the transport layer. Okay, if you go to TCP IP protocol stack, usually the earlier application gateways used to load balance depending on the IP address of your incoming request, but these are very enhanced application gateways. That's why they gave a name application gateway based on layer 7, which is basically your application layer, and they have the capability to route the application traffic to various servers. For example, if the incoming request comes with a request for getting image, then this request will be forwarded to an image server. If it comes for a web page, it will be forwarded to a web server. Okay, like that it will distribute the load. uh, well, that's said. Move forward. So I have already created one application gateway. Okay, so this is how the overview will look. Like virtual network or subnet, what is its front end public IP address? As I shown in the first picture itself, an application gateway is always associated with a front end public IP address to which all the requests will be sent. Okay, uh, that is set, and let's move on to the configuration section. Under configuration section, basically we select what kind of tier we are using. I'm using a WAF v2. Okay, capacity type, I have selected to auto scale. Based on the incoming load, it will scale automatically. Minimum instance count I have selected as 2, and maximum instance count has been selected as 10. And yes, for the HTTP2 traffic, I have enabled it already, so it works with HTTP2 also. Now, if you go to the web application firewall section, if you go to the left navigation pane, there is a particular section meant for web application firewall. So under configuration, if you see, you can specify the exclusion lists. In one of my previous videos where I have explained about Windows application firewall policies, there also we have a flexibility to provide all these options, and usually that is the place where you have to select all these settings. Okay, but same thing you can achieve at the gateway level also. So you can specify the exclusion request list which should pass through your application gateway, and also you should enable the global parameters like inspect the request body, and the maximum request body size that this application gateways allow is 128 KB. If you send more than 128 KB, you will get 403 forbidden errors for your request. And file upload limit 750 MB is the maximum limit that this application gateways allow you to send to your server. Okay, sorry, these files of maximum 750 MB basically that you can send to your servers. If it is more than that, the request will fail with 403 forbidden error. Okay, so this is how you can put constraints on your incoming requests basically, and these are all standards, guys. That's why they have created this kind of settings. Okay, so we need to adhere to these standards. And if you go ahead under same windows, under same web application firewall section, under rules, can you see this? We have not selected the OWASP 3.1. We have kept it disabled because in my last video I have already explained Windows application firewall policies, which are the global policies that we have to make use of, and our application gateways will be configured with those policies. That's why here don't enable it, keep it disabled. Okay. um, Go on. Backend pools, as I said, backend pools are the one, or which are also called as targets, which actually process your requests. So you can create a backend pool by clicking on this plus button or add button over here. I have 4 backend pools. One backend pool is meant for my backend application, sorry, my portal, that is a front end application. One is meant for my back office application which is used by back office users. One is for my chatbot application. It has its own dedicated app service, and also I have a Q&A maker service enabled. And as you know, Q&A maker comes automatically with the app service to process the request. So in total, I have four targets or backend pools which ultimately process my request. Okay, so you can go through these backend pools, how they are configured. Okay, if you click on, if you select any one backend pool, click on triple dot. Okay, and if you click on edit backend pool, or while creating an application gateway itself, you will be given option to configure your backend pools. Same wizard will be there, I think. No much difference. So if you go to the edit backend pool, see the description. A backend pool is a collection of resources to which your application gateway can send traffic. Okay, a backend pool can contain virtual machines, scale sets, IP addresses, domain names, or an app service. Okay, in my case, most of these are app services. Give a meaningful name to that backend pool, and I have given my portal application pool with this name. Add backend pool without targets. No, I have strictly said no for that. I can't add any backend pools without their targets. I must specify the targets. So in my case, target type, there are various target types like IP address or FQDN, virtual machines, app services. So in my case, it is app service. And I have mentioned the app services target or the host name which is provided by Azure. Look here, I am not making use of a SSL certificate provided to my application like www.somethingxyz.com for which I have a certificate. No, this is the host name provided by the Azure when I create this app service. Okay, I have to specify that host name or target over here. Okay, and associated rule, custom portal rule. I will soon come to the rules section, but it is already configured here. That's why you can see that. If you click on that, it will take you to the rule, but we will not go there early. So then comes the backend settings basically, which is associated with your application gateways. Again, four settings. See, it is always equivalent, it is always one-to-one mapping. If you have four app services, you will have four settings and you will have four rules, and again you will have four listeners who will listen to incoming requests. So backend settings, again four settings that I have for front office, back office, bot, and my Q&A service. Okay, so now in the backend settings, what we specify is on what port we should listen to the request. That is standard 443 HTTPS protocol. Okay, cookie based affinity I have disabled. Custom probe, web probe HTTPS I have selected, which is default. And if I click on this triple dot and go to the edit view, I can see how I have configured my backend settings. Basically, if you can see here, the backend setting name, see, I have this time I have given underscore settings to easily identify that it's a setting. So backend protocol, what protocol my backend pool should target. Basically, they should refer HTTPS protocol, they should use HTTPS protocol. And what is the port? The standard port of HTTPS, that's 443. Okay, use well-known CA certificate. Yes, here I have specified to use a well-known certificate which is associated with my web server. Okay, cookie-based affinity, it's disabled. Connection draining, it is disabled. Request timeout, important setting I have mentioned here. So the request which is coming to the backend pool or to this particular setting should last for 300 seconds. After 300 seconds, it will time out basically. Okay, so that is the first part of the setting. Then the second part of the setting comes over here where I have to specify the host name. By default, see what it says with respect to host name. By default, application gateway does not change the incoming HTTP host header from the client. Okay, and sends the header unaltered to the backend. Multi-tenant services like app service or API management rely on a specific host header or SNI extensions to resolve to the correct endpoint or to your backend pools. Change these settings to override the incoming HTTP host header. So what I am doing is basically I'm going to override the new host name. Okay, because as you have already seen in HTTP settings, I was making use of the target name as my app service name, which is your app service name.azurewebsites.net, but which it needs to be mapped to its equivalent or assigned certificate basically. That's why what I'm doing is I have selected override the new host name. Yes. Now override with a specific domain name. Now I will make use of the SSL certificate provided domain name, which is backoffice dot something 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 dot demo dot com. Okay, this is the public facing website address which the users will make use of. This is the place where this mapping will take place. Okay, so whenever the application gateway receives this particular host name in the request, what it does is basically it will map this host name to the Azure App Services actual host name and then serves the request. Okay, so that is what we have configured here. Custom probe, it's a web probe HTTPS. Okay, it is used for various health monitoring related aspects. Okay, then move on to the next part, which are the listeners. So what are the listeners? Application Gateway provides native support for WebSocket across all gateway sizes. Okay, before going to that, what are the listeners? Listeners are the one which will listen to your incoming request basically. Okay, they will read the host name. Okay, they will read the port number and then they will decide to which backend pool. Okay, or no, to which rule set this needs to be sent. Okay, not to the backend pool. So what are the specialties of these listeners? Application Gateway provides native support for WebSocket across all gateway sizes. There is no additional configuration required to enable or disable WebSocket support. So if you are making use of Signal R technologies, which are basically work on WebSocket protocol, which will exchange data continuously over a single connection. Okay, so you are not required to do anything explicitly. It will automatically take care everything. If a WebSocket traffic is received on the application gateway, it is automatically directed to the WebSocket enabled backend server, which is a backend pool, using the appropriate backend pool as specified in the application gateway rules. Okay. So that is one feature which has been provided for WebSockets. So what are the listener? Again, there are four listeners for four applications that I have. And if you go to the edit part of that listener, you will provide a listener name, you will provide the front end IP. Okay, you have mentioned that this listener will always listen to the front end IP address or the front end IP address associated with your application gateway. Okay, now what protocol it should make use of? It's HTTPS port 443. Okay, uh, here you have to make use of certificate basically. So select existing certificate which is associated with your web server or app service. Okay, and then listener type, it's not a basic, it's a multi-site listener, so make it multi-site. And host type, keep it single, and in the host name specify the public facing host name or the website address over here. Okay, error page URL I have selected as no, so I don't want any error page related URLs here. Rules, the most important thing which actually decides where this incoming request should go to which backend pool. Again, four rules are associated, and if you edit any one such rule, you will come to know the mapping basically. Okay, the back office rule I can say that I had created. Configure a routing rule to send traffic from a given front-end IP address to one or more backend targets. A routing rule must contain a listener and at least one backend target. Can you see that how the mapping is associated? One listener and then at least one backend target. It's up to you. If you have multiple app services for the same website, in order to manage the load, then you can specify both the backend targets, but in my case it's one. So one listener, one backend target I'm going to specify. So what is the rule name I have given? This is the rule name. And what is the priority? You can specify the priorities, on what priority this routing resolution should happen. Okay, so in the listener, what I have selected, my back office HTTP listener I have selected. So a listener listens on a specified port and IP address for a traffic that uses a specified protocol. If the listener criteria are met, the application gateway will apply this routing rule. Okay, so I have a listener already created. That is what I have selected for my back office application. And then comes the backend target. Okay, for this, for the previously selected listener who is going to process the incoming request, choose a backend pool to which this routing will send traffic. You will also need to specify a set of backend settings that define the behavior of the routing. So target type is basically a backend pool. There is also redirection is also possible, because you can take this request and send to some other application gateway, but that's not happening in my case. So in my case it's a backend pool. So backend target, that is back office backend pool. Okay, so my target is for back office listener. I have a back office backend pool, and settings which I had already created previously, those settings I am associating over here. Okay, because I should resolve this front end basing website to a website name which our Azure will understand. Okay, so if the incoming request comes with www.contoso.com, okay, then this www.contoso.com should be resolved to a underlying backend pool or backend target server which is going to process it, and its name is different because it starts with the app service name.azurewebsites.net. So that kind, for that kind of mapping, I have to specify these settings. So that I have already done. So rule has been specified. So now this application gateway is up and running. Basically we have specified everything, so we can start sending request from our browser to this application, and all these requests will pass through this application gateway, and application gateway will decide which request needs to be sent to which server or app service based on its URL. Okay, due to some reason, if some of your requests are failing, then basically you can, what you can do is you can go to the application gateway logs. Okay, and you can write the queries to understand what went wrong with such requests for the specified time ranges. One such example I can show you over here that I have done. See, Azure Diagnostics pipe where resource provider equal to Microsoft.network and category is equal to application gateway firewall log, where resource ID contains, specify your application gateway's name. Once you do that, it will list out in a grid all the requests it has processed, and those have resulted in errors. Okay, so using this you can identify if some of your requests are failing with HTTP status code like 403, then you can identify for what reason they failed. Most important thing I will mention here, each and every application gateway is basically associated with the Windows application firewall policies that I have explained in my one of last video. Okay, so what happens is whenever a request comes, okay, let me go to the top in order to explain it using the picture. Okay, so whenever your browser sends a request, that request will come to your application gateway. Now, apart from delegating this request to its appropriate target, what this application gateway does is it will send this request, or it will scan that request against your Windows application firewall policies. Okay, it will check for each and every possible attack like XSS attacks, cross-site scripting attacks, SQL injections, all those kind of rules it will run on your incoming request. And if it passes all those criteria or rules, then only the request will go to your backend target through a listener rule, and it will reach to your target server. If it doesn't match any one of rule, and if there are some issues with your request, like it contains some cross-site scripting attack related scripts or SQL injection related scripts or some special symbols, then such requests will be blocked. Basically it won't reach your backend target or your server. So in order to check such requests, what you have to do is you have to run these queries. Okay, and identify what went wrong. Okay, and you need to take appropriate actions. Okay, I hope you people understood the significance of using Azure Application Gateways. Trust me, in most of the enterprise grade softwares nowadays people building all those servers are always safeguarded by application gateway and Windows application firewall policies. Okay, it is a mandate, it's a standard. All your requests should pass through this pipeline. Okay, I hope you people understood the concept of application gateways and how they help you in routing the traffic to various backend pools you have, and also how to perform or how to validate the incoming request against various rules set by your Windows application firewall policies to protect your application. Okay, I hope this will help you in configuring your own application gateways and setting up the environments. That's it for today, and have a nice day.